We're talking about doubling semiconductor in the next 10 years or so. So from $500 billion to maybe $1 trillion or so. How do we create this talent that can create leadership companies? We don't have to follow how this industry started 30, 40 years ago. So we have come a long way now. Right? Arey Baba, only useless fellows will go and do this.
No,
software.
but everybody started giving their girls in marriage to that.
I know. Indians in general are very, very good at figuring out, solutions.
Hi, welcome to today's fireside chat. We could rather call it, I think, a flower side chat. The fire is only outside with temperatures going beyond 40 degrees out here in India. Good morning, good afternoon, good evening to all of you all. The morning came first, mainly because there are people from US. A large part of the audience is from US today. At 4:30 in the morning, they are here on this chat, waiting to hear our guest. I have a small prelude before we actually start the chat, and I introduce the chief guest to you all. Like most of you all know, the company that I co-found, AdAstra, is into recruitment and executive search. Recently, we were doing a search for a CEO for a semiconductor company. Every candidate we met, and it was almost across the world, had a smile on their face when they were talking about one particular person. It started me to think, and I said, why not get that person to have a talk, mainly to understand what is happening in the industry, the talent landscape, and what can we expect as a future in this industry. And that is how we crystalled on our guest, Mr. Manickam. Mr. Manickam, welcome to our chat, and thank you so much for taking time out to do this. He doesn't need an introduction, but he comes with a great academic background, IIT Kharagpur, 3 decades, 30 odd years of experience in India and abroad. He has been with Texas Instruments, National Semiconductor, founded TESOL, which grew to be one of a very significant company in the semiconductor industry, was CEO for Tata Technologies for the OSAT business, has been instrumental in teaching a lot of people and contributing to the industry. Every time he signs off on his email, he signs off as semiconductor is hard, but it is heart. And we are going to talk about it today on why he coins it that way. Just as an opening topic, one thing that my discussions with Mr. Rajaram has been very thought-provoking is, we were talking a week back, and he was mentioning to me that there is an Indian in every chip. Can we get you to give us insights on what is the thought behind that?
Yeah. Thank you, Jayanti. When I say there is an Indian in every chip, if you look at how do you make a chip, right? You have to design, right? So we have designers. Indians are the largest number of designers in the world. And then you have the EDA tools. A lot of EDA tools are actually made and developed by Indians. And then you have embedded systems, right? All that software that goes with it, and then all the design and the end system design. So if you take the entire semiconductor chain, there is some Indian that will be involved, right? And it's significant, right, in terms of number of Indians. So I always say that, right? Except for manufacturing piece, where we have some, but really not in a big way. But other than that, right, there is an Indian in every chip. Now, if you think about IPs, for example, right, the intellectual property and so on, most of the IPs are, again, for multinationals, right, will be also developed by Indians or Indian diaspora outside of India. So that's a very we should all be very proud of this. And I think one of the things that I wanted to talk about is we're talking about semiconductor in India, and we want to play to the strengths of India, right? And what are the strengths of India, right? One is we are a democracy. We just going through our elections and so on. So there is a way to democratize semiconductor, right, from the entire chain. So that's one of the key things that I want to talk about, because we're talking about doubling semiconductor in the next 10 years or so. So from $500 billion to maybe $1 trillion or so. So what happened in the last 40, 50 years, right? We're trying to do it in less than 10 years.
Which is in itself a good thing.
Yeah, it's a great thing, right? And it is going to happen. Now, how are you going to do that? Without India, without Indians, it's impossible to do this, right? So the depth of people we have, and that is why I think, as a recruitment company yourself, right, you have to spot the talent, and maybe I have some ideas later that I'll talk about, where how do we create this talent that can create leadership companies. I mean, today we talked about just NVIDIA results that came out, right? How do we create our own NVIDIAs here? So those are some of the topics that I had. One was, we talked about democratizing designs and so on, and then the amount of students, right? When I was a student, we can't even afford to go and buy books, each of us, right? So there was a tradition in IIT where the seniors used to give the books to the juniors, right? So we used to, look forward to it. And then we had libraries, right? So almost everybody would get the books from the library. We have IP library now, right? So instead of a physical book library or a digital book library, right? Why not we have a intellectual property library where students can now go and create things, right? So we're so used to teaching and learning, but not so much on creating. But now if you have this IP library and you get the students to go and create stuff, right? So right from the start, instead of just doing something for somebody else, right? You enable the creativity as a student themselves. So replace the book library
with IP
library, right? And let them make things, not learn things, make things, right?
Actually, that's what education is about, getting them to make things.
Right? And one of the reasons I feel that why the Western countries have a dominant position in this is they always encourage making versus just learning from somebody else. So we need to change some of that, right? So that's another big thing that I thought. The other one is we used to anytime you talk about semiconductor, we talk about billions of dollars, tens of billions or hundreds of billions, and so we have, in my mind, right, we have created this monster fabs and monster manufacturing facilities, very, very centralized. And my view is we need to go back to our roots when you say you do distributed manufacturing, where you make where it's needed, right, and when you need it. So when I started the industry in 1980s, early in the 80s. By the way, it's not 3 decades and 4 decades.
4 decades, okay. 3+ decades.
3+. Yeah. So now you want to when I started there, right, we were looking at 4-inch and 5-inch kind of wafers, and now we're talking about 12-inch. There's a lot of products that can be made in the 4-inch, 5-inch, 6-inch, or even 8-inch. So then the cost comes down, right? So now you could have a fab outside of Chennai, or outside of Pune, or where Tata Motors is, right? We want to make pressure, tire pressure sensors. So things like that, right? So you could have very, very functional captive kind of factories. So since in India we're just starting, right? We don't have to follow how this industry started 30, 40 years ago. So we have come a long way now, right? So for the future, we have a white canvas to draw, right? So not necessarily we have to just build what was done 30, 40 years ago and then take that roadmap. We can chart our own roadmap. So I believe that for a country, again, I come back to this thing about the strengths of India. Our strength of India is, we have a lot of engineering. We have a way of democratizing everything. We are very good at, frugal engineering. In my previous company, I used to have a printed circuit board design. So we would get designs done for state-of-the-art PCB fabs. Now, state-of-the-art PCB fabs, obviously the printed circuit board will be more expensive if you make it there, right? So one of the challenges I gave my guys was the same design, can you do it at a lower end fab? So what I call N-1 or N-2 node, right? So you bring it down. And that is where the challenge is. That is where your engineering funda needs to come in. And if you can do the same thing, which is done in the higher end fab, in a lower end fab, using your skills, right? Your engineering skills, your physics skills, and your mathematics skills. And that's when you're really creating something rather than going after the latest and greatest stuff, right? So you become more functional, right? What is usable and so forth. So I think there's a lot of things that you can do to move the the pendulum towards where the creativity, and more people participating, and you create functional products which is relevant to the people and so forth. My view is, in the last 40-50 years, semiconductor has benefited the more affluent more than the masses. Now we are at a stage where it is going to proliferate, where whether you talk about climate changing or sustainable stuff, right? So all of those things, right, which are relevant for everybody, where semiconductor is going to, and that is one of the reasons I think it's going to double in terms of the market size and so on. But you need, when you go down to that level, you need a lot more creativity, and it's very localized.
Just to add and also share with you, when we were working, we are yet working on the CEO requirements for semiconductor company. When my team did the mapping, they came to me and said, what is happening in this mapping? Is this correct? More than 75% of the mapping exercise that we had done, the candidates were Indians.
Yes.
And we were wondering, if we had got our mapping right. And highly talented, like you were saying, more than 3 decades of experience. And what was also very interesting is that when we were talking about people coming back to India to do what we are doing now, though in scale of things it might not be as big as what is happening around the world, they were more than willing to come, and they were more than willing to come into remote locations, because these are all not in main cities, and the factories are going to be in remote areas, but they were very much willing to do, which was, I think, a good encouragement. And with the change in the landscape with Make in India, I think there's a lot of buy-in. Since you have worked in India and outside, what is your view on that, of talents wanting to come back? Because we haven't seen that in most of the other industries. People say, no, I don't think we are yet ready to come back. But here we see it more than willing to be coming back into the country.
No, I think,
like take yourself for example.
Yeah, I got off the US highway at a certain point when when my kids went to college and all that. I said, if I don't get off the highway now, I will never will. Right? So I think definitely India is a story now, right? And as I mentioned, right, if it's not that we are chasing the semiconductor. Semiconductor is also chasing us, right? So without Indians in, whether it's diaspora or within India, there's semiconductors you just can't grow, right? So having said that, so the opportunities are here. Right? The other thing, from a kids wanting to be in engineering or STEM and so forth, right? India is still has a lot of pride in it, right?
Yeah.
It's a lot of pride in being an engineer or a scientist or a physicist or a mathematician, right? There's still a lot of pride. It's going down in a lot of other places, to be very frank, right? I mean, Malaysia, you know, one of the things I saw an article where they were talking about how do you get kids to go into engineering or science and so on, because they all want to become, you know, Grab drivers or Uber drivers or become chefs or something, right? Because being a chef seems to be the
biggest thing.
No, I was talking to in Singapore, ITE, right? You know, he was saying, you know, there's more people trying to register to become a chef.
I know.
How many chefs do you need in the world, right? Whereas, you know, we need, you know, engineers, or we need people who can think, you know, in this from a science perspective. So I think India has a huge advantage. Culturally, right, we respect that. So the parents push them into that kind of thing. So we have a huge advantage. Now, for us, people like me, coming back and just working with these kids, right, these talented kids, is a pleasure.
You've been doing quite a bit of that on the youth.
Right. So, you know, because the other societies are all aging, right? When I went to the US, all the people who were reporting to me were much older to me, right? And I was like, oh my God, you know, so it's always you know, you feel young when you're working with younger folks as well, right? So I think from just giving back, they feel that, you know, there's good opportunity. And when the kids come, you know, when I say kids, I mean, these are like freshers from college and so forth. It's just a joy, right? So you feel that, you know, fulfillment, right? And, you know, it's not just about money and so forth, right? Which probably you've made a lot of there anyway. So I think there's a lot of those kind of thinking that we have, coming back to the roots. As long as the husband and wife agree, then they can come. If there's no agreement, then we have a problem, right? So I think there's a lot of those kind of things that people want to give back, and they want to come back to the roots. And also, I think, you know, the fulfillment that I got from my previous company, TESOL, was TESOL currently is about 3,000 people. Through our system, right, we took fresh graduates. We would take about 500, 600 every year and train them. We had a center called Abdul Kalam Training Center. We named it after the great man.
I was there in TESOL office and I saw that one,
Oh, you saw that, okay. I intentionally named it that way. And so I think, you know, we probably created close to about 10,000 fresh grads. And a lot of them were first time graduates for their family. So, you know, you just move them from where they were, right, from the village or rural area to, you know, the next level, right? And that is another, you know, fulfillment that you have in life, right? That you have created a path for so many people. So I think, you know, there's opportunities. You don't have to really sacrifice, you know, nobody is actually sacrificing, but this is really enjoyable. So I think all of those that are adding up and people are coming. If you look at Taiwan, right, so Taiwan, you know, was very famous, TSMC is very famous. There's one man who made the difference, right, Morris Chang.
And I understand it was the same time when we started our factory in Chandigarh.
Yes.
TSMC started.
Yes. Yeah. In fact, I think SCL was maybe 1 or 2 years earlier. Than TSMC. But you know, that one man made the difference. He was actually a TI person as well. And I mean, I didn't know him. You know, he left before I joined. But he was you know, could change, right? So I always believe that, you know, if you find the right person, you could make those significant changes because of the vision that they have. And today, right, you know, if you look at TSMC, is a powerhouse, right? Right. And I see 10 years from now, you know, we will be, and we will be providing solutions to the world, to, you know, practical solutions, right?
Interesting. We've spoken about youth, and we say India is the youngest country in the world, and it is going to be for a decade plus. And we also talk about the engineers that we produce. If you look back, we were very well known for our engineering graduation education system in itself. From mechanical chemical engineering, it sort of transitioned into IT engineering, and then that became a big story. And today's topic being semiconductor, the next job creator. IT was a great job creator, and we see it going back to engineering. And it's a lot of pressure on me today with you, with me on this chat, because whole lot of questions that from the audience that we have taken. So the youth have asked, what is it that we should be doing to get there? And why is this hesitance about semiconductor in itself in our country? Is it a worry about failure, or like you said, it could be more creative, you can do it in a smaller way? So what would be your advice on the education and the way forward? Like we were talking about creativity, what people can do. Like I remember when Google started saying that you can go on our platform and do apps, there were wonderful things that came out. So do you see that happening in this space when they start creating?
Yeah. So I sign off my email saying, it is a heart, right? To me, it's a heart. And it's a semiconductor is the heart of a lot of systems, right? So it is a heart, but it's also very hard, right? Very hard to do. The reason is, you're dealing with the physical world, right? IT and all that, right? It's a software driven and so forth, right? So it's kind of virtual world. It's a lot of coding that goes on. It's, when I was in a third year, computer science was introduced, right? I was ECE, right? First time, it's 1979 or 78 or something. Computer science was introduced to IIT Kharagpur. Half my class moved to computer science, and I went to my prof and I said, no, I would like to also go to computer science. He said, "Arey Baba, only useless fellows will go and do this."
No,
software.
but everybody started giving their girls in marriage to the IT
I know.
guys.
So that was the time, right? He says, electronics is tough, right? Your smart guys should stay here, right? Let those not so smart fellows to go. But anyway, those guys all made good money. Some of my classmates were the first guys who went to Microsoft, and they're still there in Microsoft. So obviously, they're all very, very wealthy. So I think semiconductor is, in a way, it is not. There are many pieces that needs to get linked. So not one person can see the whole thing. It requires design. It requires the end user. So there's a lot of connectivity that goes on between as you build this. And then there is this challenge about what you design, and you actually create a silicon, right, or a subsystem, and that needs to work. Right now, you have to go actually, measure stuff, right? You got to measure voltages, you got to measure sine waves or square waves, or whether the logic is right or wrong. So there's a lot of physical stuff that happens, right? And then you got to link this back, right? It's a very iterative process. And then you have the fab processes, which are lithography. So you got physics involved. You got materials involved, right? A lot of materials involved. So you have all kind of things. You got material science, you have mechanical, you have optical, and then you have the design guys, right? And then you got the guys who got to do this debug. So I think so it is not that very straightforward in say that all I need to do is learn coding, and I can become a software engineer, right? So I think from that perspective, it's a little bit harder, but it's not rocket science again, right? I have this tendency of whatever is difficult, you break it into small pieces, and then you attack each piece, right? And then you integrate it. So that's how you build things. So I think you should start from a school, right? Where, like I said, right, make them do things rather than learn things. And once they start doing things, right, and you can even do it in your native language. People now with all these AI and all that, right? So you can learn electronics in Tamil, right? It's okay, right? It's like Japanese, right? You know, they do all their stuff in Japanese. I mean, you go to Taiwan, right? They have a tough time, talking in English. Or you go to Korea, right?
Which opens up a big world out there.
Correct. And I think with this, I'm not an expert in AI and so forth, but I think with all those, language learning and so forth, I think because you tend to be more creative in your native language, right? I mean,
we think in our native language.
Yes, right. Rather than trying to convert people to become English speaking, right? English to me is just a tool, right? You need not be a master in English. Right? It's just a tool to communicate, right? To reach out to all these people. But I don't need to be a native English speaking capability, right? I don't need that.
You don't need grammar.
I don't need it, exactly, right? Especially now, right? You don't need it. So I believe that, you can teach in your native language and they can become more and more creative. And you start them young, right? You start them young. I guess in schools now, they already start doing computer science and writing some apps and this and that, right? So bring, a semiconductor, right? As I said, right, I don't mind, we have about 60, 70 IPs in my company, right? I don't mind offering it to the government, right? And say, okay, but we want the schools and colleges to motivate and monitor, and how they're using it, make it easy for them to use, and then have fabs and all that which can actually take that, whatever they've created, right? It could be a small thing, say a doorbell or something, right? Doesn't matter. But they would have learned something. So I think once they start doing some of those things, they'll become more relevant. You solve this issue about, oh man, this is very complicated, right? So I think just like IT and so forth, the opportunities are coming, and Indians are very good at grabbing. They know where they can smell opportunities. So there is a role for government to play. There is a role for the universities and colleges to play. I think especially the private colleges, if they start focusing on this, providing some IPs, providing some actual small fabs. Like for example, I have working with somebody who is building a very what we call a 4-inch fab, right? Very tiny fab, which you can make a lot of sensors and MEMS and all that, right? So it may cost about $8 to $10 million to set up a fab like that. There's a lot of limitations, but it's really suited for development work.
When I've been talking to a whole lot of candidates outside of the country for bringing them into the country for the knowledge that they can bring to the table, and we hear different things from them. They tell me probably manufacturing is not the best of the things. Packaging, advanced packaging, testing could be more smarter things. We hear things like India can manufacture, but where is it? We are going to be competitive on pricing, and who is going to buy it from us in this competitive world? And you were talking about how we could be smart and how we could pick up smart things in the value chain. And since we are in the starting phase and there's so much happening in the country, where do you think we should be smart in focusing and getting our act right?
Okay. No, very good question, right? See, companies work on financial metrics, right? What I call these companies ROI companies: return on investment, return on equity, IRR, right? These are the big, the Tatas of the world or CG Powers of the world. So they're all very large companies. Their decisions are made on financial metrics. Their decisions are not made on innovation, right? Let's be very clear about this, right? I believe in this area, in semiconductor, techies build companies. So, Jason is still running it. He's an entrepreneur. Lisa Su, AMD, right? She's a top-notch techie, right? So was Morris Chang. Morris Chang was one of the leading, fab manager operations.
What a success story.
Yes. So all of these, right? The founders were techie people. So they, business people have not created semiconductor companies. Now they may have come in later stage, right? And then take over a running company which is tens of billions, or and then they make it 3-4 times or so, right? But I think techies build this. In this area, I'm a big believer that the moment you put financial metrics, you can't get off the ground, right? So the question of whether it should be in manufacturing, right? You do the financial metrics, it will come negative. China is better, or cost, for whatever they manipulate, right? There's a lot of manipulation that's done there, right? It's not very open. Whereas in India, right, most companies in India are either profit. If there's no profit to be made, they won't exist in India, right? So we have a check and balance, right? Whereas China, a lot of companies will be losing money, but it's a national goal or whatever, right? And they're okay with that. They can even operate with 2% margins, right? In India, there's no way, right? If you go to any of these big companies, right, the first thing they say, show me
profitability.
Yeah, IRR has to be 18%, or your margin has to be 25%, and so forth. So I think semiconductor doesn't fit that, at least at the early stage, right? So I think one of the we have to have manufacturing in India. We have to have. The reason is, with all the designers and IP creation we have, if we don't have, as I said, right, you have to see the physical thing. You have to see the physical thing, or debug it, and then you feedback. If that doesn't occur, you stop, right? Your innovation, so you're still in the virtual world, right? So you have not and that piece is very hard to develop. Why, in fact, I put it in my LinkedIn post, right? What is common between Lisa Su, Jason Huang, and TSMC, Taiwan, Morris Chang? They're all Taiwanese, right? Although Morris came from China, but he basically built that. So I'm sure there is a link for them to be successful, right? Taiwanese buy from Taiwanese, right? Japanese buy from Japanese. Koreans buy from Koreans. Chinese buy from Chinese.
I like the answer.
Right? But Indians, we don't have that industry to buy from Indians, right? We have all the designs, right? So we have to create it, right? Europeans will buy from Europeans, right? Try selling, to Mercedes, right? They will buy from a European company, right? So I think, we need to, from that perspective, right? There are Indian companies which will buy from Indians if it exists. So we need to have manufacturing. There's no question about it, right? Now, does it make IRR and ROE and ROE? No. It will over time, right? 5 years, and that is what I think government is trying to do with the financial gap, right?
And there's so much support from the government.
Huge. So and that's why I said, right, government has a role to play in helping the manufacturing piece of it. Now, I would suggest to the government, I take this opportunity, that 20% of what they are giving to all these large companies, take that 20% of it and invest in two things. One is some of the big changes that could happen, right? And I'll tell you what they are. So invest in that. Take some bold decisions, right? Like our Chandrayaan mission, right? A bold decision, right? So you make a bold decision. Take a bet on 2 or 3 things that is going to happen in the next 10 years from a semiconductor perspective. The other thing is, second thing is, take a bet. You do your own due diligence. Take a bet on some of these techie guys. And just like Taiwan did with Morris Chang, take a bet on somebody like that, right? Who has a passion, who wants to do this. So coming back, right? So what are the opportunities, right? I see in the next 10 years. One of them that I just recently came about was there's a new standard that's coming up called NTN, which is satellite-based communications, cellular to satellite type. It's a low power,
low orbit.
yeah, it's a low orbit satellites. It's a it's a good fit for India, right? So India has the strengths in space, right? We should be launching satellites now, right? So we have a lot of strengths there. We have a lot of strengths in and this with the cellular, right? You need low power as well. So from low power, and this may not be for streaming video or something like that, but it would be very good for low data rates. So for example, right, India needs we need to monitor a lot of our agriculture land, right, which is all over, right, millions and millions of acres of land. So you need a lot of sensors that goes about, and you need to propagate it in a very low cost, and they are only transmitting at a very, very low data rates. So it's an ideal example, right? So there are many applications like this, right? So NTN could be, right? I'm not saying that should be it, but take one of those things, right? So that is a bold initiative. Go fully back it, right? Maybe government needs to put $100 million behind it, right? And put a team across it. Because we are at an early stage, right? All over the world. So we have a level playing field now, right? Yeah. We are not behind. So take some of this. The other one, I work with Venki Sundaram, right? He's a big proponent of glass.
He has a list of questions for you.
He's got a glass-based substrate that he's talking about. So that's another bold initiative, right? May work, may not work. So what? Even if it doesn't work, right? Maybe it doesn't work 5 years. Maybe it'll take 10 years, right?
We have done.
Because these are some gray area, right? But that technology, the wisdom, how to do that, it's already here, right? And then you take it to the next level, right? So, but it's risky,
Yeah.
And it may not work out as a business plan. It may take longer, but I think
it is a good opportunity.
It's an opportunity, right?
So interesting you're talking about this. Like when I've been talking to candidates, they tell us, yes, this government initiative, there are business houses that want to start, but I don't think we are there on the infrastructure. Looking at it positively, I think that's a great opportunity. Like, so I was asking questions as to, I'm not as much an expert in semiconductor like you. So they were telling us that we don't have double iodized water facilities. Accessibility is another issue. Going back, if you look at it as an opportunity, there's so much related industries and ancillary industries that have to come up to support semiconductor in itself. And coming from where we come from recruitment and talent management and talent creation, that's going to be a huge job opportunity of people, and with they're going to be definitely transition or a newer pie added of talent coming into engineering. What is your take on infrastructure related to semiconductor? You touched upon one piece of it, but we are talking about double iodized water, climate change, so it leads to a whole lot of other questions. Yeah. Can you give us your take on it?
Sure. So I think, this infrastructure thing is being actually played up too much in my opinion, right? We are very, very good at, especially private sector is very good at figuring it out.
It's a great opportunity.
Yes. And we have world-class companies in India. We do have world-class companies, right? Not only in the service sector, even on manufacturing, right?
I think we underplay on that.
We underplay on that, right? I mean, I was told about, we have the largest leather producing, we have the, like forgings, right? I mean, we make world-class forgings, right? I mean, right here in Chennai, right? In Tasol, we design some of the boards which are world-class, right? Meaning it's 40 layer, 60 layer, 80 layer, boards for test engineering and so on. And they are very thick boards, very complex in Coimbatore. We do things like that, right? So I don't think, if you give it to the private sector, they'll figure it out, right? Number one. And you're really not talking about, the good thing about semiconductor is it's very tiny, right? So you're not talking about, creating multiple places, huge ecosystems. If Singapore can do it, come on, you live in Singapore, certainly, right? We have the wherewithals to do it. And always, people talk about, oh, we don't have water, we don't have this, we don't have that, right? Intel is putting up a fab in Arizona. There's no water there. It's a desert, right? It's very hot, right? You need, imagine the amount of air conditioning required, the amount of power required to keep these fabs going. Nobody questions that. But when it comes to India, right, people say, oh, there is no water, right? We'll go create water, right? Or we'll put in places where there is water.
Yeah.
And now we're talking about recycling, right? There's technology that, you can recycle about 90% of the water.
Sewage water to drinking water.
Right? So you can, it's done in Singapore.
Yeah.
So I think, all those are, you can overcome that. And I think, Indians in general are very, very good at figuring out, solutions. Hopefully it's a more permanent solution, not band-aid solutions, but I think, you just leave it to the private sector. I think the other way. I think a lot of people globally are worried that if India gets into this, we could dominate this space.
I think, that fear is happening. It's the elephant that is coming up.
Right.
Yeah.
So we have to take charge of our own destiny. Foreign companies are not going to come here and help us do this. We have to control our own destiny, create our own companies in leadership positions.
So I think we really need to be proud of what we produce. You look at what we have done in space,
Exactly.
and engineers we have produced, and of course IT piece of it. It has been a significant contribution to the world.
Exactly.
Yeah.
And there's a lot of pride in it, right?
Lot of pride in it. So I'm also going to take few of the questions from the audience, because they have been nice to be awake at 4 in the morning for us. So how many jobs could be created in India's advanced semiconductor plants, including primary, secondary and tertiary jobs?
I don't know the exact numbers, right? But I would say, for every high-end job, direct job, my guess is there'll be at least 7 or 8 other jobs, right? Because like you said, right, it requires a lot of ecosystem, it requires a lot of supply chain coming in. Like, I'll give you a good example, right? Rather than, I don't know the exact number, but you say for example, you have a fab. Now you got to make the equipment for the fab, right? Now once you start making the equipment for the fab, then you got the guys who are supplying nuts and bolts and these other things for the equipment, right? So that there's another industry that goes around that, right? CNC machines and something like that. And then you've got chemical industry that will come. Then you've got transportation that is going to be involved. So I think this can create a lot of other jobs as well. And the other thing is we are underplaying the. See, today the way it works is. You have a chip that is designed. It's what we call, usually it's a multi-purpose chip. It can do a lot of things, right? I think with the democratization of design in India, what will happen is you will make maybe 10 times more new designs. So you'll have the number of designers is going to increase, right? And then you're going to have pockets where you'll have designers, software guys, and all that. In a small rural town, right, and they will kind of, have a niche that they will do. Yeah. So I'm not able to pin a number, but I would say easily, if let's say a fab is producing 10,000 people direct jobs, it could be about 100,000.
Yeah, significant percentage. I'm sure. You almost answered the second question, but I'm going to read it out not to disappoint the person who sent the question. What skills are needed for semiconductor manufacturing in India beyond VLSI design and embedded software? Are these skills available, and what training initiatives are needed at the BTech and ITI or polytechnic levels?
No, I think, see, again, running the fab itself, right? A lot of it is automated these days, right? So it's um, debugging, creating new processes and so forth, right? Chemical related, process related. I think those are classes that you should start putting in, in the undergraduate programs. But I think we have a lot of programs already in place, whether it's IITs or otherwise. We are producing people for the world, right? The question is, to keep them here, right? See, who are running all these things, right? Is usually our guys who are going to Germany, or they're going to
100%.
US, or they're going to somewhere, right? Or even TSMC, right? How many Indians are working in TSMC processes today, right?
Significant.
But TSMC has a program, recruitment program at IIT Bombay, right?
True.
Right. So our guys are there only, right, doing this. So I don't think it's a question of what we need to do. I think we already know what to do. And there is a lot of work that can be done by technicians and so forth. So I think it has to percolate down, and the number of people needing directly required on the fab and manufacturing is very, very small. So we don't need to worry so much about it. We have the programs.
In fact, you were talking about starting a semiconductor academy.
Yes. So Semiconductor Academy focused on entire flow. So I come from the back end. I'm not a wafer fab guy, so post fab. So we're trying to set up packaging training type of hand, wire bond, mold, and those kind of. It's a lot of mechanical stuff and so on. So we're trying to establish it in multiple cities where students can go in. It's once you get that familiarity, then that fear goes away. Right? So a lot of it is on the job training.
And I think that's one thing which is big time happening in our country. It's geographically spread. Yeah. It's not getting concentrated on the so-called main cities. It is going back of beyond, and I think that's a great thing for job creation, especially.
Sure.
Opportunity for people. What is your take on that? Is that going to be good for the industry?
No, I think it is. It is good, as I said, right? And I'm a big believer in distributed manufacturing, and each place will have its own strength. See, Coimbatore is very good for mechanical stuff, right?
Winding
winding motors or stuff like that, right? So they're very good at it, right? And Pune has got his own strengths, right? So we have different pockets which are good in different things, right? So let that to drive those, right? So we're thinking, working with the Tamil Nadu government on this, where we're thinking about setting up equipment parks specifically for making semiconductor, EMS or solar equipment, right? So it requires a lot of CNC machining, sheet metal, and stuff like that. So those are the so you see where the pockets are, which has got some inherent strengths, and then you work on that.
You want to throw some light on what you have started now, AJK Next Semi. We promise we'll not talk about you, but this is something a lot of people in the audience wanted to know what was happening.
So actually the AJK story, I don't want to, it may take a little bit of time, but it's not AJK anymore, it's called IVP. I think I told you about AJK, but IVP is a fabless chip company that I've started. I focused on the power sector. So we are actually starting to sell our own, Indian-made chips. Although the fab is not in India yet. So when the fab comes to India, we'll start fabbing it in India. We're focusing on power sector because power is going to change quite a bit in India today, right? You got the renewable energy, solar based. So there's a lot of electronics that goes into it. It's a government initiative, right? And then you have all the EV chargers and the EV market, which also requires power. So I think the whole grid is going to change. So we're going to play that. My view, as we change the grid and the requirements, right? I want to capture all that market. I want to be the guy that semiconductor guy that all these.
I'm sure. We'll see the passion. I think that's very important. We at Adestra, we are very much into diversity. So I can't help but ask this question myself. It's less than women in the semicon industry is less than 30% as of now. What would be your advice for the fairer gender to come into the industry? And how is it that we could improve not only gender, it could also be physically challenged and visually challenged people? Yeah. Where is it that we can work on the employability space?
Yeah. No, I think, in fact, I think it's a very good question. I wanted to address this as well. When I was in TI, right? TI had a very unique position where, I'm talking about early 80s and so on, where men were really dominant, right? Women were not, even if they were good in physics or science and so on, right? They were never to be seen. But TI, very uniquely, had a lot of engineers who were women, and they rose to become managers.
What a company,
right? So I was fortunate, to see how they work. And the other example, right? In the recent example is ISRO, right? ISRO, there's a lot of we were really
all women
surprised. Yeah, we were actually surprised, right? Pleasantly surprised, right? So I do believe that bringing those these girl students from high school, right? They're very good in science and encouraging them to go into this, right? And then actually have a scheme, right? Whether it's in private sector or public sector. But I think maybe from a talent search, maybe one of the thoughts I have is identify some of this and take them through that whole journey, right? Because they need that help, right?
And just to share with you, we do especially women in management, we do a mapping just to ensure that they don't drop out for reasons other than, of course, everybody, quite a few people, both the genders drop out of jobs, but sometimes without much thought they drop out, like your husband's getting a transfer and they say, okay, I stop working and stuff like that. So those are the things we actually keep a mapping and see if we can bring them back to the career path. It helps actually. I think that little chat with people really takes the percentage higher.
So I think, in this area, I feel that we are the bigger loser, right? If we don't get that 50% which are smart, they're smart people, right? So if we lose in the end, right? So my view is, just like you're doing this mapping, right? Do that for STEM or science based or engineering based, right? And you bring them up, right, into the industry. Even in my batch, right? I mean, we had 2 girls in my batch, right? And then then IT kind of computer science, encourage more, right? But if I look at where they are, right? Who graduated in the first 10 years of ECE, most of them ended up as professors or somewhere, right? Not so much of the industry. And I wasn't a topper in class or anything, not even close. But the topper was a girl, obviously. For some reason, it's always a girl. And she's a prof, in one of the big universities. So I think as a recruitment, and I think maybe there could be where you map this at a very early stage, and give them the guidance and so forth, right? Role models to look at. And ISRO is a very classic example how they do it. Maybe you need to do a case study on that, right? How they survived.
We have met a few of them. Yeah, it's very, very interesting. And like many other things, like we talk about how we underplay our strengths.
Correct.
And you take it for granted and you sort of underplay the whole thing. But having said that, you see some of the best Fortune 500 companies these days are headed by women.
Yes, and in science as well. I mean, if you look
STEM
at Intel,
specialists,
they are some of the very techie positions in Intel and all that are women.
Yeah, very much.
And so again, we place to our strength. In India, I tell you, as compared to all other Asian countries, women do have better position in engineering and so on, right? I mean, if you look at Japan or you look at Taiwan or you look at many other countries, right? Or Korea, for example, right? You hardly hear about any Korean lady, you know, in Samsung or something.
That's true.
Right?
Yeah.
You hardly hear about in Japan either, right? They're all very advanced countries. But you do hear in India.
India has a large percentage of working women.
Yeah.
On that, I'm going to take one more question. It's since related to diversity. How will semiconductor industries impact job creation in India, and which type of jobs, engineering, manufacturing, R&D, will see the most?
I think engineering by far in terms of number of jobs is going to be very significant. Manufacturing, I think, you know, there will be like lower level and in a higher level. I think in the packaging and all that, you know, you may have more technician type of activity. In the fabs also you'll have some technician, but more on engineering. So I think overall, I think engineering or related, whether it's, you know, polytechnic or engineering, I think that will be the largest trend, I think. Now, R&D, I think we have great R&D with, you know, whether IITs or Indian Institute of Science. I think the challenge there is how do you take that R&D and actually bring it to mainstream, right? So we have great, you know, minds working there, but how do you take it to, you know, becoming great products, right? Because if you see, most of semiconductor that was created came out of labs and institutes, right? Whether it's AI engine or Google or anywhere, right? So it all came from them. But we don't have much to show for.
Yeah. But talking about R&D itself, just to share with you, we do a lot of work in the automobile space, and it's not necessarily like the GCCs that have come. There are 1,800 plus GCCs in India, and it is beyond cost arbitrage and real estate arbitrage. It's about talent. You see advanced and more complex talent requirements, that those requirements are being addressed out of India. We do a lot of work on human machine interface, because most of the vehicles are becoming smart and of course driverless and whatever. So you see them coming into India in a very, very large scale, which I think is an advantage for us. So R&D seems to be taking a front seat.
Absolutely. So the thing is, you know, you got to recognize that.
Yeah.
Right. So while you recognize a manager or you know, finance you know, base or CEO and so on, I think we don't recognize as much on the R&D guy. So, you know, give them that kind of recognition, right? You know, it's great to be an R&D guy. It's great to be a technologist, right? I think maybe, you know, there's some fine tuning that you need.
We don't have an assessment tool for it, right? To talk about it.
Yes.
Any advice on that? To showcase the talent that we have.
Yeah. See, you know, a lot of companies, right, are started by CTOs, right? You know, very, very techie guys, right? And then at some point, right, it becomes a business decision, and then, you know, but still, the technical people are the ones who are given, you know, a lot of pride and recognition, right? I really don't know, you know, I mean, within TESOL when we did, right, we gave a lot of, you know, we say we are engineering intensive company, right? So our goal was we were engineering intensive, right? So the more the talented engineer, the more experience we give them recognition, right? So they versus the, you know, the pure managerial type of people, right? So I think that needs to, you know, in this industry, this is what will make the difference.
Yeah, and we do have case studies and examples of reverse engineering that has happened. So which I think shows that we have some of the best brains in the country.
Yes, there's no doubt. I have no doubt about it.
Yeah, I think we are almost coming to the end of the thing. We were there. We didn't know how an hour passed by.
I enjoyed it.
I thoroughly enjoyed it. And like I said, I'm sure there's going to be a whole lot of other questions from the audience, which we will mail it to you. This popular demand for a second event, which we will try and see how we can accommodate based on your availability. As a something that you want to tell the audience.
Yes, thank you, and thank you, Jaydev. I know I wanted to send this message. I said, you know, I think we are in a great time. Semiconductor is flourishing. It's going to change the world. It's a good thing for the world as well. Technology is going to really shape the world, in a good way, right? Sustainability and all the other issues that we have. Technology has a solution. It's only a question of how you adopt it, right? And India can be the leader in this, right? So I think I would encourage more students or kids and also leaders, right, to get into this opportunity that is coming up. I could say this is the next after the IT, where we have a very, very strong position. So, and I think government has to play a role. And the government's role is to support the innovation, because we have to control our own destiny, create our own companies to go do this. How we do it, it's we can go into the nuances about it, but it's a great opportunity for all of us.
For all of us. Now, talking about the government initiative, most of our clients who have got into this semiconductor space tell us that they are behind us, they are there for the inauguration, they have been very, very proactive in the whole thing, be it subsidy, be it following up on the project. So I think that is a great encouragement, great time to be in India for us, and I'm sure we'll all do well with the type of brains we'll have. And we're talking about privatization and giving it to the private, and I think what is also helping and coming up as an excellent case study is public-private joint ventures. Those are happening. We hope and we'll keep our fingers crossed on this industry coming up as one of the best. Thank you so much. We can't thank you enough for this. We had a great learning. We look forward to continued conversation on this. Yeah. Thank you all. Thank you all so much for the time. It means a lot for us. Please send us questions and we'll be able to send you all answers on the mail. And if it is too many questions, then we'll have a second section. Thank you.